Hi guys, welcome back to my geometry tutorials. Today I'd like to go over some definitions. The first definition I want to look at is that of a point. So a point is actually an abstraction. It just represents a position in space, and it doesn't actually have a length, a width, or a thickness. But when we work in geometry, we obviously want to know where a point is, so we use a dot to kind of locate um, where um, a point is in space. So that can be a little bit confusing, but just remember um, from the more precise definition that it actually doesn't have a width, or it's infinitely small. A segment is, if we think about it loosely, a segment is actually a straight line that has two endpoints, and the endpoints are literally the stopping points for that straight line segment. I like to think of a segment actually as a set of points. A set is a collection of objects, so let's say, for example, the set of numbers between 1 and 5. Well, the set would be 1, 2, 3, 4, 5. So we have 5 numbers, so 5 elements inside the set. For geometry, we're actually thinking as a set of points, so we need to think about it visually. So let's see what's going on here. So we can actually kind of construct a segment just knowing the fact that it's a set of different points. In the first case, x is a point between endpoints A and B. So I choose x here, but you can choose x here or here or here. So there's actually an infinite number of ways you can choose point x such that it's between point A and point B in kind of like a straight line. But you can also choose, in case 2 and case 3, you can also choose point x at point B or x at point A. So when we consider all these different possibilities, we get a segment that has a definite beginning and a definite end. I'd like to move on to some other definitions. So a line is actually an infinite extension of a segment through both endpoints. And a ray is an infinite extension of a segment through a single endpoint. So when we think of an extension, you just have to remember that an extension is just kind of like pulling out a line farther than its endpoint. So this will make sense when I actually look at a diagram. So let's say we have segment AB. So this is an endpoint, this is an endpoint, and this is a segment right here. So by extending the segment, we're just kind of continuing it past its endpoint. So for a line, we are extending the segment through both endpoints. So it goes this way and it goes this way. And we can extend it infinitely in both directions if we wanted to. And again, I like to think of this in terms of a set of points. So let's take point x. So if point x is on the extension of segment AB through endpoint A, x can be anywhere to the left of endpoint A. So I chose it here. It can be here. It can be here. There's an infinite number of ways you can do that. Another possibility is that x is equal to endpoint A here. The third possibility is x is between endpoint A and B. So we saw that same scenario with the segment AB. So you can pick point x here, here, here. There's infinite number of ways you can pick a point x between A and B. So this is actually a typo. I'm sorry about that. So here x is equal to point B, and then in the final situation, x is somewhere on the extension of segment AB to the right of endpoint B, and there's, you can extend this as long as you want, and you can take it in infinite many ways. So when you kind of add up all these different possibilities, you get a line. So you get this kind of line passing through these endpoints A and B, and just to remember that it's a line, the extension has to go through both of these endpoints. For a ray, we get an extension of a segment AB, but only through one endpoint. So there's a definite endpoint here, and we don't extend it past whichever endpoint we choose for the ray. So here I chose endpoint A as kind of like the stopping point here, but for point B, we can extend this as far as we want. So we see these different cases. We have 4 different cases. We can choose x as endpoint A, x as some point between A and B, x equal to point B, or x on the extension of segment AB. So anywhere to the right here, there's infinitely many points, so we can add up all these points to kind of visualize what a ray looks like. Okay, so now I want to go over a question here. What special properties do segments, lines, and rays have? Well, one property is perpendicularity. So perpendicular lines meet at right angles 90 degrees at a single intersection point. Parallel lines never meet when extended infinitely. There is no intersection point. So let's take a look, let's visualize what's going on here. So we take 2 lines, AB and CD here, and this intersects at point M. So there's only one intersection point between these 2 lines. Now if we measure this angle AMD, the measure will be equal to 90 degrees. So you can measure it with a protractor. Maybe there's something online that measures angles, but when 2 lines are perpendicular, they always meet at a right angle, and the right angle is 90 degrees. So actually when you have 2 lines intersecting, 2 perpendicular lines intersecting each other, there's actually 4 right angles that are being created. We can also think of 2 segments being perpendicular, or 2 rays being perpendicular, but I want to keep it more general, just using lines, and we can kind of generalize from that. So parallel lines never meet each other, so we have to kind of use our imaginations a little bit. So I created 2 lines here. The first line is EF, and the second line is GH. So in order, obviously these lines have a definite kind of length. They're inside this slide, so obviously they don't extend forever and ever, but we need to kind of think of it, well, what if we extended this line infinitely in both directions, right? And then we did the same for this line here. If these 2 lines are parallel, they basically will never meet, no matter how far we extend both of these segments. So there'll never be an intersection point between these 2 lines, and that's what parallel lines actually means. Okay, let's visualize. Okay, so let's go over what types of shapes we can build using points, lines, segments, and rays. So the first kind of shape we can create is a triangle. A triangle is made by joining three non-collinear segments. So what does non-collinear mean? Well, basically it means all 3 points are not on the same line. So you we'll be able to look at that in a minute. Just remember the triangle is made up of three distinct segments. A quadrilateral is kind of a similar idea, except we're joining four non-collinear segments together. A circle is kind of like a set of points that are all those points are the same distance from a point called the center of the circle. So let's say you have a circle of width, a radius 1 foot, for example. We can pick, so if we look at the center of the circle, we can pick a point. You just, I don't know, you use a ruler or something like that, and then pick a point that's 1 foot away from the center, and then pick another point that's different from the first point, but that's also 1 foot from the center. And then if we pick infinitely many points, and we kind of like join these points together, you get a circle. And the last definition I want to look at is an angle. So an angle is actually the joining of two non-collinear rays. So remember, a ray is different than a line. It's different from a segment. The rays, when we join these two rays together, the point which they share in common is called the vertex of the angle. So let's take a look at some of these shapes here. So ABC is a triangle, and we can see there are three segments, AB, BC, and AC. So we joined all of these segments together to get a triangle. And they have to be closed, of course. So we can see that there are only three vertices to this type of shape. Okay, so let's look at this quadrilateral. So this is made up of joining four segments together. So segment DE, EG, GF, FD, and creates a closed kind of geometric figure. And okay, so now we're going to move on to a circle. So a circle is not, it doesn't have a straight line boundary like the triangle and the quadrilateral, but if we took a point that's the center of the circle, then we can see all these different points here on the circle are equidistant from the center. The last definition, so HIJ, so we have ray HI, ray HJ, and we can see that the angles actually joining these two rays together, the common vertex is H in this point. Let's look at some more definitions. So we talked a little bit about angles before, so let's be a little bit more specific. A right angle is an angle that measures 90 degrees. A straight angle is an angle that measures 180 degrees. These come up a lot, complementary and supplementary angles. So a complementary angle, complementary angles, if you measure both of the angles and if you add the measures together, you get 90 degrees. Supplementary angles, same idea. If you add the measures of both the angles together, you get 180 degrees. So let's take a look at some examples. So here ABC is a right triangle. If you want to measure this angle, it would be 90 degrees. So, you know, just think, it looks like an L. It has like an L shape. Right angles do. a straight angle is 180 degrees. So 180 degrees, it actually literally looks like a straight line. So um, if you started from here, E, and if you measured this angle here, it would be 180 degrees. So a straight angle pretty much looks like a straight line. So these are the kind of more detailed concepts here. So if we look at these two rays here, this is actually a right angle. So if we did GHJ, and if we measured it, it would be equal to 90 degrees. But let's take a look at angle GHI. So this is equal, I don't know what this the measure of this angle is, but obviously it's smaller than 90 degrees. But if we look at this other angle here, IHJ, again, I don't know exactly what the measure of this angle is, but if you see, if we join these, so if we add the measures of both these angles together, you get 90 degrees, because if when we join these two angles together, we get the right angle GHJ. So we say that angle GHI is complementary to JHI. Let's take a look at the supplementary visual here. So we have a straight angle here, KLN. So if we measured this, this is basically a straight line. So this angle measure would be 180 degrees. But we can see there's actually some two different angles here. KLM, so this angle here, and then angle NLM, this angle right here. Again, I don't know what the actual measures of these two angles are, but if you take the sum of the measures of these two angles, you would get 180 degrees. Why? Because this is a straight line. So when you join these angles together, you get a straight angle. So we can say that KLM is supplementary to angle NLM. The last thing I want to look at are some special segments that occur in triangles. So the first type of segment is an altitude. So an altitude is basically a segment from the vertex, from any vertex of a triangle, and if we extend that segment to the opposite side to the vertex, we get two perpendicular segments. So I'll show you what this looks like when I do a visual on the next slide. A median is a segment that joins the vertex, any vertex of a triangle, with the midpoint of the opposite side. And then the last thing is an angle bisector. So just remember, any type of bisector, they don't have to be just angles. Later on, you'll see what a perpendicular bisector is, and I don't know if there's other possibilities, but to bisect means you're dividing it into two equal parts. So an angle bisector means you have a line or segment that divides an angle into two equal angles. So let's take a look at the visuals here. So here's what an altitude would look like. So you have triangle ABC, and we choose a vertex, any vertex. It could be B, C, but I chose A. And we draw a segment from point A, and the segment that's actually opposite to point A is point BC here, or segment BC. So we draw this segment in such a way that these two segments are perpendicular. So this AXC is a right angle 90 degrees. And that's basically what an altitude looks like in a triangle. And let's look at the median for a triangle. So the median, again, you choose a vertex, any vertex you want, and you create a segment that joins the vertex of a triangle with the midpoint of the opposite side. So in this case, segment EF is the opposite side of vertex D, and Y is the midpoint. So this distance EY is equal to YF. So these two segments are equal length, and you just basically draw a line from point D to this midpoint, point Y. So this was kind of a quick tutorial about some basic geometric definitions. So I want you guys to look over these definitions before we go further into depth in when we do problems. It'll be very important to remember what these definitions actually mean. Okay, well, thank you for watching, and I hope you guys have a great rest of your day. And please, hopefully you'll watch my next tutorials that are coming up soon. All right, take care. Bye.